Now that we have an understanding of why reference angles are important, let's establish how we can figure out reference angles given some other angle. There are a few steps to be able to find out what the reference angle is. The first step is you'll have to add or subtract 2 pi or 360 degrees, depending on if you're working in radians or degrees, until you have a coterminal angle between 0 and 2 pi or between 0 and 360. So between 0 and 2 pi or 0 and 360 degrees if you're working in degrees. So let's write down an example that we'll do as we list the steps. So let's find the reference angle t prime for t equals 11 pi over 3. Now, if 11 pi over 3 is between 0 and 2 pi, you don't have to add or subtract 2 pi. So let's check. So 11 pi over 3, how does that compare to 2 pi? Well, to compare, I'll multiply by 3 over 3, which is 6 pi over 3. And clearly, 11 pi over 3 is bigger than 6 pi over 3 because 11 pi is larger than 6 pi. And so I'm going to take 11 pi over 3 and I'm going to subtract 2 pi from it, and I'm going to get a coterminal angle. So subtracting 2 pi from 11 pi over 3 will give me 5 pi over 3. And now 5 pi over 3 is between 0 and 2 pi. If you compare this to 2 pi is 6 pi over 3, and 5 pi over 3 is less than 6 pi over 3. Now, if you had to add or subtract 2 pi more times, then do that, but in this case we only have to subtract 2 pi once. And of course it's worth mentioning that you'll have to add 2 pi if you have a negative angle. Now the next thing you'll have to do is you'll have to find the quadrant that your angle lies in. So remember, quadrant 1, those angles lie between 0 and pi over 2. Quadrant 2, those angles lie between pi over 2 and pi. In quadrant 3, those angles are between pi over 2 and 3 pi over 2. And quadrant 4, we have 3 pi over 2 less than t less than 2 pi. So we ask ourselves, which one of these quadrants do we lie in? Well, we're asking ourselves for 5 pi over 3. So 5 pi over 3 is clearly larger than pi because 5 is larger than 3, and well, if you convert pi, or if you multiply the numerator and denominator by 3, you get 3 pi over 3. So this is clearly larger than pi, so it's not going to be in quadrant 1, it's not going to be in quadrant 2. Is it in quadrant 3? Well, to be in quadrant 3, you have to be less than 3 pi over 2. So is 5 pi over 3 less than 3 pi over 2? I suppose we don't know that yet, so let's put a question mark. So we'll get a common denominator, and the left-hand side will end up being 10 pi over 6, and the right-hand side 9 pi over 6. And so this is not less than 3 pi over 2. It's bigger than 3 pi over 2. And it is going to be less than 2 pi because, well, 5 pi over 3, 2 pi. 2 pi is 6 pi over 3, and so this is less than 6 pi over 3, and so we are in quadrant 4. Once you have determined what quadrant your angle lies in, you can draw a sketch of your angle in that quadrant and come up with a formula for the reference angle. So my angle that lies in quadrant 4, so it looks something like that. That's T. And now my reference angle is the smallest angle between the x-axis and the terminal side of my angle. That's this here, T prime. And once you draw a picture like this, depending on what quadrant you're in quadrant 4, this picture looks like this, we will see that there's a relationship between T prime, where if you go around by T and then you go forward by T prime, you make the angle 2 pi. So that means that in quadrant 4, this is only going to work in quadrant 4, this particular equation. T plus T prime is equal to 2 pi. Because if you go around by T and then you go around a little bit more by T prime, then you make one full revolution, and one full revolution is 2 pi. Finally, we can use this equation resulting from our drawing to figure out what the reference angle T prime is. So here what we're doing is we're drawing a picture, write an equation for T prime. So we've done the picture, we've written an equation, then all we have to do is find T prime. So in this case, T, which is 5 pi over 3, when you fill in this value of T, you're going to use whatever you found after you subtracted 2 pi or added 2 pi the number of times that you needed to in the first step. So in this case, we're going to use T as 5 pi over 3, not as 11 pi over 3. So our T value, 5 pi over 3, plus T prime, which we don't know. That's the whole point of this exercise, is we're trying to figure out what is the reference angle that is equal to 2 pi. And so in order to find the reference angle, I can subtract 5 pi over 3, and I get that T prime is equal to 2 pi minus 5 pi over 3. And on multiplying by 3 over 3 to get a common denominator, I find that my reference angle, T prime, is pi over 3. I think it's probably worth mentioning why in the first step we can simply add or subtract 2 pi or 360 degrees if we're working in degrees. It's because when you add or subtract 2 pi or 360 degrees, you get a coterminal angle. And coterminal angles have the same reference angle as the previous angle. So that is, in this problem, 11 pi over 3 has the same reference angle as any angle that is coterminal with 11 pi over 3. So in particular, with 5 pi over 3. And it's much easier to find the reference angle for 5 pi over 3 because it's between 0 and 2 pi. So a few steps: add or subtract 2 pi so that you get a coterminal angle that's between 0 and 2 pi. Find the quadrant that T is in. Then draw a picture, write an equation for T prime, and find T prime. Now if your angle T lies in quadrant 4, then you're always going to come up with this equation when you draw your picture. T plus T prime equals 2 pi. But if you have an angle that's in a different quadrant, then you'll get a different equation. Let's see what those look like. So the easiest one is in quadrant 1. In quadrant 1, your angle looks something like this. So this here is T, and T itself is its own reference angle. So t equals t prime. So if you find that your angle is in quadrant 1, there's almost nothing to do. You just write down the reference angle is its own angle. In quadrant 2, we're not so lucky. So in quadrant 2, the picture would look something like this. So there's my t, and here is my reference angle, t prime. And what you might notice is that if you start out by going a value of t, then of course you'd end up on the terminal side of t. And then if you go a little further by t prime, where do you end up? Well, you end up with an angle of pi. So this would be equal to pi. And then you can figure out what t prime is. T prime would be pi minus t. Now, what about in quadrant 3? So in quadrant 3, we have the following picture. There's circle. Here's my angle t. And my reference angle looks something like this, t prime. And I can come up with a formula for the reference angle by noting that if I go a distance of pi, or an angle of pi, and then I go further by the reference angle, then I end up at the terminal side of t. So this is going to be equal to t, and that allows me to determine what the reference angle is here just by subtracting pi from both sides. T prime is t minus pi. And finally, in quadrant 4, we've already drawn the picture, but let's draw it again. We have that our angle is in quadrant 4. So that's what my t looks like. And there's my t prime. And now, to come up with an equation for my reference angle, I note that if I go around by t and then go a little bit more plus t prime, the reference angle, then I get to the angle of 2 pi. And so my reference angle is going to be 2 pi minus t. So you have one of 4 drawings and equations depending on what quadrant you end up in. The easiest one being quadrant 1, where the reference angle is just the angle itself, and then the other ones vary in difficulty.